Oh, wow, that was loud. Okay, so the first thing we're going to start out with is if you have, just draw two lines that intersect. It doesn't have to look exactly like mine, but just two lines that intersect. I actually don't like that those look like 90-degree angles. I want them to look like they're different. When you have two lines that intersect, it creates four angles. Angle, I'm going to label them angle A, angle B, angle C, and angle D. Four different angles. My mind is just stopping. Does anybody know what's true about angle A? The measure of angle A and the measure of angle C. From your past experience with angles, Keegan, they are the same. They are called congruent angles. They are vertical. Please write down the word vertical angles. You won't necessarily use it on today's homework, but you will use it when we start doing proofs. Just angles review, yeah. So vertical angles are created when you have two lines that intersect. And sometimes the pictures get really crazy. There's triangles and lines coming straight through the middle and parallel things. But in general, when you've got two lines that intersect, it creates these vertical lines. And I look at them as they are. So when two lines intersect, the vertical angles are the ones that are opposite each other. They're the opposite of each other. They're not neighbors. They're not next to each other. They are opposite of each other. So one way I like to think about it is like a reflection. So if you think about butterfly wings, if you fold butterflies in half, they are a reflection of each other. There's some letters in the alphabet that when you put them down the middle and fold them, they reflect, like the capital letter A. B reflects this way, if you draw a reflection line this way. So if I think about reflecting angle A over, I can picture that those look congruent to me. Okay? So if you're trying to memorize all these things, think about a butterfly wing. And again, folding this over, C and A are clearly the same angle because we've got straight lines. All right, I'm going to draw another set. When you have intersecting angles, you have two sets of vertical. So I like to name them X, O, and X and O. So draw yourself a second set of intersecting angles, label them X's and O's. X's are congruent to X's, and O's are congruent to O's because they're vertical. They're a reflection of each other. Does anybody remember what happens when I do X plus O? Ian. It adds to 180. So same exact picture, X's equal X's. So if this is 25, this is 25. If this is 50 degrees, this is 50 degrees. If that's 120, that's 120 degrees. But O's plus X's equal 180. Does anybody remember the geometry vocabulary word that goes along with that concept? They are supplementary angles. Supplementary angles have a sum of 180 degrees. Some people call them a linear pair. When I asked the last period, what is it called? Somebody said, it's called a flat line. I would never use that on a proof, but these are from flat lines. That's true. So if I've got this flat line and I've got two angles that are created off of it, supplementary angles. And it goes all the way around. This flat line, this flat line. So we've reviewed vertical angles. We've reviewed supplementary angles. So quite a few years ago, I was teaching 6th and 7th grade in Colorado. And they'd hired another teacher the same year as me. And she was a theater major and a math teaching minor. I've never met a theater major math teacher. She had one of those voices that projects on stage, and you could hear her like clear down the hallway. So I heard her in her class teaching this, and I thought it was so funny. It's this concept of, so draw yourself a 90-degree angle. Actually, why am I on this page still? That does not even look 90 degrees. So she was trying to teach this concept of when you take a 90-degree angle and you split it into two parts. So let's call these angle X and angle Y. So the measure of angle X plus the measure of angle Y equals what? On this picture. 90 degrees, it's a right angle. So when we start doing geometric proofs, and I say, why does the measure of angle X plus the measure of angle Y equal 90? You can't say because it's a right angle. There's theorems that you have to use. So does anyone remember what this one's called? Complementary. So this is what Miss Bott would do. She would walk around her classroom like this with a right angle with her arms. And she would say, compliment people, it's the right thing to do. Compliment people, it's the right thing to do. And you want to know what none of them ever forgot? That the right angle, when you add them together, they make complementary angles. I know, I had to channel it. Compliment people. She even had an accent. Can you picture this lady? She was fun. She was very loud. I actually had a kid transfer into my class because she was too loud. That's not a lie. Sometimes there's too much of a good thing. Okay, so these are complementary angles when two angles add up to be 90 degrees like these ones would. Okay, so I asked my last class, who likes geometry? Do you guys like shapes? And one kid said, I like shapes unless I have to try to do algebra to find parts of them. So if you like shapes until now, when we give you this type of thing, we might say something like the measure, I just destroyed my whole picture. The measure of this angle is 3x plus 5, and the measure of this angle is 2x. Find x. Like that's how we take geometry and make it also algebra. So how can we use our complementary angles theorem to find x? Yes, Addie. Yeah, so we now know that this is 2. We're going to call it 2x. Thank you. We're going to call this 3x plus 5. And because they are complementary angles, we know they'll equal 90 degrees. So take a second and solve that. We're just going to practice it. Where are you sitting now, Haley? Oh. Let me give you your worksheet. This is a review, so I'm thinking you'll be able to figure it out, or at least most of it. Compare with your neighbor. See if they got the same x as you got. It might not be a whole number. I just made these equations up right now, so it could be a decimal. I really don't know. I don't see you all comparing your neighbor. Davis, you can jump the aisle and compare with Ian. He's not doing it. He's refusing to take notes. Carter, did you compare with your neighbor? Hayden, did you compare with your... Okay. Did you compare with your neighbor? That looks like a lying face. Did he compare with you? Okay, compare answers. Make him do it. I didn't ask for the measure of the angles. I just said what is x. So we'll just stick with x. Ashlyn, what did you find out that x was? Just 17? I got a whole number? Does everyone get that? Wow, that is the first time ever that I've made numbers up and they're actually like good whole numbers. Okay, from there it could go back and say, what is the measure of this? And you would do 2 times x, and what is the measure of this? It's kind of like substitution, which we've been doing. But this is the gist of how you will use some of these formulas and algebra together. Okay, supplementary, complementary vertical angles. Okay, sometimes our pictures get a little more difficult. So we will have a set of parallel lines. Please do your best to draw a set of parallel lines. And then a transversal. I'm not even going to apologize that this is so easy because we've done a lot of hard stuff this trimester. This is kind of nice. Okay, so if I tell you that this is x, fill in your x's and o's. X's are equal, o's are equal. X plus o is 180. Okay, when you have parallel lines, and they're not always parallel, but when you have parallel lines in a transversal, can you picture this angle specifically right here, this O? And I'm going to translate it, which just means you slide things around. You're not rotating, you're not making them bigger or smaller, you're not reflecting. We're just translating it straight down. Can you see where its matching O would be? They are called corresponding angles, but I don't think we need to know all those vocabularies today. So I can, in fact, take all 4 of these, translate them down. Do you see it? There's lots of alternate interior angles, alternate exterior angles, corresponding. We're not using them today, so I'm not going to throw all of those at you, but that is the truth. Yeah. No. We've left them in the dust. Okay, so I want you all to answer to me. If I tell you that this x is 100 degrees, oh, wait, I got to do something else first. We're going to call this angle 1, 2, 3, 4, 5, 6, 7, and 8. So I'm going to tell you the measure of angle 1 equals 100 degrees. I want you to find the measure of angle 2. I want you to find the measure of angle 3. I want you to find the measure of angle 4, and 5, and 6, and 7, and 8. Equals. And it doesn't take very long, but write it down. X's are equal. O's are equal. X plus O is? Not everybody all at once now. X plus O is 180. And I only have to tell you one. The measure of angle 1, this one right here, is 100 degrees. Find all the missing ones. That's a step in the right direction. Trying to give everyone time. The measure of angle 3 is not 100. Because I didn't go in the circle, because I jumped over, you got some that are the same, right next to each other. Okay, Baxter, what's the measure of angle 2? How do you know that? Say it again. Well, why? How did you know that? What kind of angles are they? He remembered my annoying thing. Yes. In geometry, when we get to proofs, if you tell me something like that, you have to be able to give me a theorem or a definition of why. And it's the hardest part of geometry, so I'm going to force you to start doing it now. Lacey, what's the measure of angle 3? How did you know that one? How did you know that? What's your vocabulary word we remember today? Oh, did you do this? So how did you know this was 80? Vertical angles. So Baxter knew that these together had to be 180 because they're supplementary. And Lacey knew that these two were the same because they are vertical angles. You have to know the why. It can't just be because they look like it. No, not good enough. Hayden, measure of angle 4. Why is it 100? How did you know that? It's vertical to the one that was given. This one was given. That one is vertical. I love it. Peyton, measure of angle 5. There you go, 100. How did you know that one? How did we know they were x's? So you might say on this one it's a translation. It's a translation from angle 1. You can't just say because. You have to come up with vocabulary words from geometry. Allison, what's the measure of angle 6? How do you know that? Allison, how do you know that? What's your reason that you knew it was 8? Those above. So that one, with the information we have, I haven't given you the vocabulary words yet, the specific ones. It's a translation. That's what we're going to say up till now. Like I said, if we use proofs with these, I'll give you all the other vocabulary words. Ethan, measure of angle 7. And Carter, measure of angle 8. Okay, as silly as that seems, that's important to go through and think about why. Are they vertical? Are they supplementary? Is it a reflection? Is it a translation? Okay, let's draw ourselves a triangle. The really long side. They're not always 90 degrees, but this one's going to be. It doesn't have to be a right triangle, but I'm going to make it. I like right angles. Adelaide, do you know what I'll get if I add the measure of angle A plus the measure of angle B plus the measure of angle C? Do you know what that has to equal? Yes. It's called the triangle angle sum theorem. So if I say how do you know or why, that's what you'd have to tell me. So let's write it down. The triangle angle sum theorem. So some of you aren't writing anything down. I would suggest you write down vertical angles, supplementary angles, complementary angles, and triangle angle sum theorem. Unless you literally have like a photographic memory and can just bring that up in a few weeks when we do proofs. All right, so let's do a problem here. What if I tell you that the measure of angle A is 35? Please find the measure of angle C. How am I supposed to do that, I wonder? Find the measure of angle C, and then I'm going to have you compare it with your neighbors. So you got to write it down. Find the measure of angle C, compare it with your neighbors. I don't know which way it's supposed to go. My mind just glitched. I think it's supposed to be the other way. Mm-hmm. Yes. Yes.
And then we take that whole sequence and then we just speed it.
Yes. Exactly.
Can you do the perception?
Maybe. Okay. Ask your buddy. Hopefully they had enough time. So, Sophie, how do I find the measure of angle C? Just 35? This one's a little tricky because I didn't specifically tell you it was 90. I just gave you the angle. So the measure of angle A is 35. The measure of angle B is 90. We don't know C, but we do know it equals 180. So Sophie, what did you find that it was? Did everyone get that? Okay. Find the measure of angle D. Think about all the different relations we talked about. How do you find the measure of angle D? Go ahead and give it a shot. And compare with your neighbor. Some of you already found it. So if you have not already found D, find D. Devin, did you find it? I don't know, is it? Okay, compare with your neighbor. Ethan, what did you have for the measure of angle D? How did you get that? How did you know that they were equal to 180? Yes. These two are supplementary angles. They are a flat line. So he did 180 minus 55, gave him the 125. Okay, there's another theorem. You're definitely not going to be forced to use it for today's homework, but I think it's kind of fascinating because who would rather add than subtract? I know I would. So there is a theorem that states an exterior angle of a triangle, so it's created by extending a side out. This is called an exterior angle. Not this one that's touching it, but these other two. If I add these two together, I'll get the exterior angle. So instead of subtracting from 180, which you can still do, you can just add these two together, 90 plus 35. Does that give us 125? Yes, and here's kind of why. We know that the measure of angle C plus the measure of angle D equals 180. So we know this is the supplementary one that Ethan was helping us with. This is the triangle one. So if these match and these match, these have to be the same thing. Those two opposite angles in the triangle added together will equal the exterior angle. So you don't have to use that theorem. Let's write it down just in case you want to. It's called the exterior angle theorem. So if you want to draw yourself a picture, on this picture you would have the measure of angle A plus the measure of angle B equals the measure of angle C. These two that are opposite of it equal the exterior angle. Kind of a fun one. Okay, we're just going to do a few practice problems, and then you're going to have way too much time to work on your homework, which will not be homework. Yeah, today's lesson's just a fun review, which I think you guys have earned. What do you think? Maybe you wanted to do more hard stuff. We will get to it, I promise. Did everyone get that who wanted it? Some people are still writing. I'll wait for a sec. Exterior angle theorem. Now that I'm thinking about it, it might be the triangle exterior angle theorem. I don't know. I'll fix it later if it needs to be fixed. Okay, your homework paper has two sides. The first side just gives you triangles or parallel lines with transversals, and you're using vertical angles or supplementary or complementary, or you're using all of these things to find these missing angles. The other side, every single picture has a set of parallel lines and a transversal, and you're just trying to find what x is. Okay, so if this is 15 degrees, write on your paper what x is. And I'm going to have you compare with your neighbor, and I'm going to ask somebody to tell me what they think it is. And we'll just do a couple different ones like these. They get a little bit more difficult. Okay, ask your neighbor what they got. Camden, what did you get for x? Why is it 15? They are alternate exterior angles. What have we learned today, could you say? You'd have to do vertical, so you'd have to know that this is 15, right? Vertical, and then what? There's almost two things you have to do with the vocabulary from today. So once you do that, then how do you get down here? Yes. So it's a reflection and a translation. That's how we get down here. Again, there's lots of vocabulary words we can memorize. If you can understand the concepts, to me today, that's what's important. You can visualize how to get from here, reflect it over, translate it down. I kind of like that. Okay, let's try another one. What is x? This is the problem like this that most people missed in class for some reason. So find x. Show your neighbor. See if they got the same x as your x. Are they giving out fishies again today? There were so many smashed fishies on my carpet yesterday. Poor janitor. Oh, so hopefully they got them for free. They're 2 days past this. So there's a lot of preservatives in these, right? Oh, yeah, that's why Spencer texted me. Can you excuse my absence? I was like, why are you missing? It was for my daughter's wedding. Okay, sorry, that's way too much time. Carly, what did you get for x? It won't be degrees because it's just the x. Well, is the whole angle 30 degrees? Did you find the whole angle or just x? Okay, so I'm just not going to put degrees. It's just 30. What is the measure of that angle, though? So it's not 30. Some of these are two-step problems. So are these two angles equal? No, they're an X and an O. And what happens when I add X's and O's? 8 equals 180. You guys are kind of shy sometimes. Okay, so I know that 120 plus 4x, these are X's and O's. I know they equal to be 180. They are supplementary angles. And then you can solve from there. Subtract the 120, divide by 4. Okay, let's try 2 more, and then I'll let you guys get started. 2 more. What is X? Oh, that can't work. Impossible. Let's put you right here. Sorry. There we go. Now find X. That other one was just a trick question. So think about the angles we've talked about today. If they are right next to each other, what do they have to equal? Okay, it looks like most of you are done typing and writing. Compare your answer with your buddy. I'm looking at everyone to see that you compare. Baxter, don't be shy. Are you guys being shy? Tanner and Kevin, did you guys compare? Sophie, who are you comparing with? You're what? Okay. So you kind of have like weird gaps right here, so you guys could just jump over the aisle and compare. That might be a good idea, actually. All right, Jada, what did you get for X? How did you get that?
4x.
How did you know that that was true? Yes, I don't have a creative way of remembering that. Complement each other. It's the right thing. I don't have a cool way to remember supplementary. So once you know that they're right next to each other, they're supplementary, these are all geometry truths that some fabulous mathematician figured out and we all agreed with because we tried it a million times. Once you divide, you get 36. Okay, my last one. I think I've already done the hard ones. That can't be true. Let's try this again. Sorry, this is what I get for not making up the problems beforehand. That went kind of crazy. Okay, 10x, 120. Find x. That's just 10x. I don't know what happened. The marker just went down. Find x. Are these equal? Do they add up to be 180? Those are the two things we're kind of thinking about. Okay, compare with your neighbor. I don't think this one's going to take very long. Eliza, what did you get? 12. How did you know it equals 12? How did you find that? Yep. These are equal for a lot of different reasons. We've got the vertical and a translation. They are alternate exterior angles, which we did not really talk about or write down. Okay. If you happen to get done very quickly with your paper, because some people are going to, don't get your phones. Don't wander around, right? So find something quiet to do. If you didn't finish your test, that's a good time to finish it. If you weren't even here yesterday and you need to take it, it would be a good time to take it.